Okay, number 7 on the midterm review. This is another mixture problem. It's a different scenario, but works very similar to the last word problem, number 6. This one says, a solution containing a 9% concentration of acid is mixed with a solution containing a 5% concentration of acid to get 100 milliliters of a solution containing an 8% concentration of acid. How many milliliters of each solution is needed? So we're mixing two things together, this solution, the 9% solution, and this solution, the 5% solution. And what we want to end up with is 100 milliliters of that 8% solution. So the question is, how much do we need of the 9% of the 5 and the 5%? So those will be our variables. So we'll need X milliliters of the 9% solution. And since our total amount is 100, that means 100 minus X will be how much we need of that 5% solution. So let's set up our equation. Our equation is how much acid is in each item or each solution, I guess. So we know that 9% of this one is going to be acid. So that's 0.09 times X, the number of milliliters, plus the acid in the second one, that one is 5%. Oops, not 0.5, that would be 50%, 0.05 times the amount of that solution. And that has to equal 8% times the amount of the final product. We have 100 milliliters of that final product. So we're going to go ahead and do some distribution here. Pen's not wanting to change colors. I don't know why. I guess we'll stick with blue, navy. 0.09x plus 0.05 by 100 is just 5. 0.05 times negative x. And 0.08 times 100 would be 8. Combine our like terms here. And we get 0.09 plus 0.05 is 0.15x. We'll subtract that 5. And we come up with 3 divided by 0.15, which is 20. So x is 20. We look back at our variable definitions. That would means we are going to have 20 milliliters of the 9% solution. The question asked how much of each, so we also need to do that little calculation. 100 minus 20 tells us there are 80 milliliters of the 5% solution. So those are our answers. Okay, next up, we have a nice little quadratic equation here. It's asking us to solve by completing the square. So completing the square is one of our quadratic solving techniques. We also sometimes do factoring or maybe quadratic formula, but this one gives us real specific directions, so we need to make sure that's how we solve it. First up, to complete the square, we need to have a 1 as the coefficient of our x squared term. Right now, we have a 3 as that coefficient. So our first step is to divide both sides of the equation by 3. On the left-hand side, you need to make sure you divide every term by 3. So 3x squared divided by 3 leaves us just x squared. We also take the negative 24x divided by 3 and the negative 33 divided by 3. 0 divided by 3 just stays 3. First step, get your coefficient of your x squared term to be 1. Next up, I'm going to move that 11 over because what we basically need is any term with a variable in it will stay on the left. And I'm going to leave a space here for my next step. Any term without a variable will go over on the right. And I leave that space there again, setting myself up for the next step where we're actually going to go in and do the completing the square. When we complete the square, we add a number into this blank that gives us a perfect square trinomial over here on the left. And that value is determined by b over 2 squared. For us, b is negative 8 over 2, which is negative 4, and we square it, and that gives us 16. So that's the number we want to fill in. We're going to add 16 on the left. We got it added on the right too to keep our equation balanced, to keep it equal. This now should always factor, if we've done it correctly, into a perfect square trinomial. X squared leads to that x in the front. 16, you take the square root, and that gives me the 4. And the -8 in the middle determines that sign. So this is x minus 4 quantity squared, and that has to be equal to 27. Now we can use that square root property to solve. We are going to take the square root of each side of this equation. When we do that, on the left, the radical and the exponent cancel each other out. On the right, don't forget, we do need a plus or minus in there. We need to go ahead and add 4 to both sides. And then we should also simplify. The square root of 27, it's not a perfect square, but it does simplify. If you have the multi-view calculator, you can simplify square root radicals on your calculator. It is 3 times the square root of 3. So there gives us our final answer. We added the 4 over, so we get 4 plus or minus 3 square root of 3 for our solution. Next up is another quadratic equation. This one doesn't tell us exactly how to solve it. It just says find the exact solutions. That means we don't want any rounded decimals. We want the symbolic answer. Probably is going to have a radical in it. So when I look at this one, I'm not going to think about factoring that, not with those fractions in there. Well, and honestly, I'm not going to think about anything with those fractions in there. I'd like them gone. The easiest way to handle this one is going to be to clear out those fractions. And if I multiply this entire equation by 9, that is going to cancel out both the fractions I have here. So that is going to leave me with a 9x squared. When I multiply it into the next term, the 3 in the bottom and the 9, we get some canceling going on there. So instead of 4 times 9, we just have 4 times 3. So -4 times 3 leaves me with a -12x because the 3 canceled with one of the 3's out of the 9. And then my last one here, the 9's cancel altogether, and I'm just left with -1. I can tell pretty quickly that this one does not factor, so I'm going to go ahead and use the quadratic formula with A is 9, B is -12, C is -1. Make sure you take the signs of your coefficients with you. X equals -B, so we get minus the -12, plus or minus the square root of B squared, minus 4 times A times C, all over 2 times A. Go ahead and do some simplifying. First thing is those two negatives knock each other out, becomes +12. We can probably simplify everything under the radical there just with our calculator. Make sure if you are squaring a negative number, you put parentheses around it because you want to make sure that that negative value gets squared, not just the 12, but the -12. So -12 squared minus 4 times 9 times -1 is 180. So that's what's under my radical. And I'm guessing that 180 will simplify down further. The square root of 180 is 6 times the square root of 5. And there is one more simplification step we can take here. We can do some reducing. If you look at our coefficients, we need to look at all terms, so all 3 of those values, but they are all divisible by 6. So we can divide each one of those yellow highlighted numbers by 6, and we get 2 plus or minus square root of 5 over 3. That would be our fully reduced and simplified answer. Number 10, we're moving on to complex numbers. The problem's over here on the side. It asks us to simplify this. We do need to follow our order of operations when we do that. So we would want to square this piece first and then do the subtraction. It might be helpful to square that to actually see what that looks like rather than written with the exponent, write out the 2 factors. And then we're going to go ahead and FOIL that. So 6 times 6 is 36. And then 6 times 5 is plus 30i. And then we get another 5 times 6, which is another 30i. And then we get for our last 25i squared. We'll copy the rest of that down in a second. We do want to combine these two like terms in the middle. And then the other key thing to remember is that I squared is equal to -1. So what we have right here is 25 times -1. So when we go to simplify, that is actually -25. The I goes away altogether because that's -1. 25 times -1, we get -25. So then we can combine those two like terms. 36 minus 25 is 11 plus 60i. Now that was just the yellow part. I still need to subtract off 9 minus 2i. Be careful, that negative sign has to carry through the parentheses to subtract that complex number. So it ends up being -9 plus 2i. Combine your like terms. 11 minus 9 is 2. And 60i plus 2i is 62i. There is our answer in standard form, the real part and then the imaginary part. Another complex number problem. This one is a division problem. The directions say simplify. They could also say divide. They could also say write in standard form. But when we see this type of problem, what we need to remember here is that our goal is to get the i's out of the denominator. So this is kind of like rationalizing the denominator. We are going to multiply this fraction by, oops, a little crooked there on my line. We're going to multiply this fraction by the same thing on the top and bottom, so we don't change its value. And the value we want to multiply by, the expression we want to multiply by, is the conjugate of the denominator. The conjugate means take that middle sign and flip it. Okay, it was a plus, so when we multiply through, we want to multiply by a negative. Then what we need to do is FOIL out the top and FOIL at the bottom, and let's see what we get. Up top, 3 times 4 gives me a 12, and then a minus 9i, and then a minus 20i, and then a plus 15i squared. Let's do the same work on the bottom. FOIL it out. The 4 times 4 gives me 16. 4 times negative 3i, positive 3i times 4, and 3i times negative 3i. Okay, there's everything multiplied out. We do have some simplifying that needs to happen. Let's look at the top first. We'll combine those two like terms in the middle, and we'll also take care of that I squared, which we remember is -1. So that's 12 minus 29i minus 15. On the bottom, anytime we use this conjugate, this is what should happen in the middle. We should get a positive and a negative that cancel each other out. And then again, that I squared changes the sign, so we end up with 16 plus 9 in the denominator. 12 minus 15 is -3. And 16 plus 9 is 25. The final step we want to take here, whenever we are talking about complex numbers, we always want to put it in that a plus bi form. So we want the real part of our answer, which would be -3 over 25, followed by the imaginary part of our answer. So we do want to split that into those two fractions. We should check if either one of those fractions can be further reduced. In this case, it cannot. So we are good. Okay, number 12 on the review, we have an absolute value problem here. When we're solving absolute values, whether it's an equation or an inequality, either one, the first thing we want to do is get that absolute value part of the equation or inequality by itself. So before we do anything with the absolute value, we are going to isolate that part of the equation. I'm going to subtract 14 from both sides. 29 minus 14 is 15. And then we want to divide both sides by that 3. Now we can deal with the absolute value symbols. Remembering that absolute value is a distance. It tells us how far away something it is, but not which direction it is. So whenever we have an absolute value, we need to split it into a set of 2 equations for an absolute value equality. So either 2x minus 1 has to be positive 5, or the opposite of 2x minus 1 has to be positive 5. The distance has to be 5, either to the left or to the right, to the positive side or to the negative side. So we solve each one of these independently. They're pretty easy little equations from this point. In the first one, we get 2x equals 6, and then x equals 3. On the other one, we'll distribute that negative sign, so minus 2x plus 1. And then we want to do the same solving. We subtract 1 from each side. Divide by -2. And so we get two answers, x equals 3 or x equals -2.